So I'm not sure why I included the idea of proof here, because the actual proof of this is much more complicated and goes into a bunch of probability lemmas and axioms that we don't really need to get into for our course. But the idea being still that probability of A given B, I need to find where A happens knowing that B has already happened. So intersect over probability of B. But what comes out of this is very interesting. So if I move this to the other side, then I have the probability of A intersect B is probability of A given B, and I'm not sure why this is this forward slash. It really should be straight up and down, times probability of B. But I can also think of the probability of B given A. So in this case, given A, I know that A has happened. B happens in the intersection. So that's going to be A intersect B, but now divided by probability of A. So I can say that probability of A intersect B is also probability of, B given A times probability of A. So I've got two different ways of thinking about my intersection as well that comes out of my conditional probability. So let's see if I can apply some of those and go with just probabilities. So if I have probability of A is 0.5, probability of B is 0.3, and the union is 0.7. So I know from my addition law that the union is probability of A plus probability of B minus the probability of the intersection. So that tells me that the intersection is going to be A plus B minus the union. So 0.8 minus 0.7 is 0.1. So then A given B is going to be 0.1 divided by probability of B. B given A is going to be 0.1 divided by 0.5. Probability of not A given B, so let's think about this one. I'll just make a quick little Venn diagram box here. So given B, again, that means I'm looking only in this circle, but then not A is going to be this area and this area. So I want not A given that B happened. So let's fill in some of my numbers here. I know that I had 0.1 in the middle. So 0.1, 0.4 for A, 0.2 for B. So this is what I need to know. I need this 0.2 here. So not A given B is going to be 0.2 divided by my B, which is 0.3. Or of course I could write that as 2/3.